Okay, this is question number 10 in paper 2, section B. So this question is about the circular measure. In the diagram, okay, it shows the right angle triangle, very important information, LMN, inscribed in the semicircle. Inscribed in the semicircle, that means all the vertices are on the circumference of the circle with the center O here, whereby LM is 4 cm, MN is X cm. So we need to show that the area of the shaded region A is given by this equation. Now let's solve this part. Yeah, how do we solve? Now, first we have the semicircle with center O, and then the LM, which is inscribed in the semicircle. It's a right angle triangle, and this is 4 cm, whereby this is x. So we want to show that the area of the shaded region. How do we find the area of the shaded region in the first place? Isn't it we take the area of the semicircle minus the area of the right angle triangle? Yeah, so area of the shaded region is equivalent to the area of the semicircle minus area of the right angle triangle. So what is the formula to find the area of the semicircle? Now we can use the admits. A equals to half r squared theta. So half. And what is our r? Do we have r? It's not given over here. We have to find. So never mind, just put down the formula first. Half r squared theta. The theta is actually this. It's 180, so pi. Whereby area of the right angle triangle will be half times the base times the height. So half times 4x, which is 2x over here. Now, our objective now is to find what is the r. Okay, how do we find the r? We can use the Pythagoras theorem to find the diameter. So the diameter of the circle will be, this is Ln, yeah? That means diameter is Ln, can be found by taking the sum of the square of the two sides. So it's square root, and therefore the radius will be half of the square root of 4 squared plus x squared. Okay, now, so let's put the r squared in our formula here. So half times half, the r is 4 squared plus x squared. And don't forget, the r squared, got to square it, and then pi. The rest just copy. So this one left with 2x. Next, let's open up the bracket by square whatever inside the bracket. We have half here, pi, and this side will be 1 over 4. And this square root, after we square, we get back 4 squared plus x squared. Okay, should have put the square bracket right from the start. Okay, and then minus 2x. Now let's open up the bracket. So 1 over 2 times 1 over 4, we have 1 over 8 pi times 4 squared, which is 16, and then plus x squared, and then minus 2x. Okay, let's multiply this thing in. We will have 2 pi plus pi x squared over 8 minus 2x. Let's check whether it is given as the same as the a over here. 2 pi, pi over 8x squared, pi x squared over 8, yes, minus 2x. So we have just shown that the area of the shaded region is given by this equation. Now, next part, we have to find the value of x such that a is minimum and find the minimum of a in terms of pi. Okay, so when you see the keyword, a is minimum. So a minimum, we use the differentiation concept. when we differentiate A towards the variable. In this case, A is written in terms of x. So towards the x equals to 0. So differentiate this one. Now pi has no variable. It's a constant over here. So it's 0. After we differentiate, it's 0. So we differentiate this one, we will have 2 pi x over 8 minus 2 equals to 0 over here. So we will have pi over 4x equals to 2. Therefore, x will equals to 8 over pi. So we have found x when a is minimum. And let's find the a minimum in terms of the pi. So a minimum will be, now a is given by this formula. So 2 pi plus pi over 8. Now the x will replace with the value, which is 8 over pi squared. Yeah, because pi x squared over 8, and then minus 2x, and the x is 8 over pi. Okay, then solve this part. We will have 2 pi. This is 8 over pi. So we have 2 pi plus over here, we will have pi over 8 times 8 over pi times 8 over pi minus 2 times 8 over pi. So you see, pi over 8, 8 over pi can be simplified. Yeah? So we're left with 1 8 over pi. So 1 8 over pi minus 2 8 over pi, we will have over here 2 pi minus 8 over pi as our answer. So this is the area minimum for the shaded region. Double check, one variable minus 2 variable, we have negative the variable. Yeah, correct. So this is our final answer for part B, A minimum. That's it.